Edexcel IGCSE Chemistry quick revision of section 1 particles and mixtures. Elements, compounds, and mixture. An element is formed of only one type of atom. It can be an individual atom or it could be a molecule of more than one atom like chlorine, oxygen, and hydrogen. A compound is when two or more different atoms are chemically combined, and they're represented by the molecular formula, which gives you the exact number of the elements within the compound. The different components of the compound or the different atoms cannot be separated by physical processes because they are chemically combined, and the properties of the compound is different from the properties of the elements that form that compound. A mixture is formed when two or more different elements or compound are mixed together. They are not chemically combined, and in air is an example of the a mixture which has different components like carbon dioxide, water, vapor, nitrogen, oxygen, argon. The properties of the mixture is a mix of the properties of its component, and the different components of the mixture can be separated using physical processes. The process of separating the mixture of the component will depend on the nature of that mixture, whether it's solid and liquid or mixture of liquids or a mixture of solids. Filtration is used to separate insoluble solid from liquid using conical flask funnel filter paper. The mixture of the insoluble solid and in a liquid is then poured down the filter paper. The residue is the insoluble solid that remains on the filter paper, and the filtrate is the one that passes through the filter paper, and this is the filtered liquid. Evaporation is the method that is used to separate soluble solid from liquid. You use an evaporating dish and heat it with a Bunsen burner. The water or the solvent will evaporate. You leave it until the solvent evaporates completely and only the solid remains. Crystallization is another method to separate soluble solid from a liquid. In this one, you first heat the solution using an evaporating dish where only some of the water evaporate. You keep heating that until the solution gets concentrated and crystals starts to form on the walls of the evaporating dish. This is called the point of crystallization. Then leave the solution to cool down and to form crystals. Finally, you filter the crystals that are formed, so you separate the solid from the solution. If you want to separate a component, a mixture of solids, like the separation of the component of rock salts, which is a mixture of sand and salt. Sand is insoluble in water, while the salt, which is sodium chloride, is soluble in water. You start by grinding and then you dissolve these two components in water, where the sand will not dissolve while the salt will dissolve. You filter then, so the residue that will contain the insoluble sand, while the filtrate will contain the salt solution. Finally, you take the salt solution and separate the salt using crystallization. If you have a mixture of a solid or a solution which has a mixture of solid with solvent or with a liquid, you can separate the liquid using simple distillation. You have your solution in a round bottom flask and you heat it using a Bunsen burner, where a steam or vapors will start to form. The vapors will pass through a leading condenser which has cooling water in from the bottom, water out from the top, and then the condensed vapors or the condensed liquid will be collected in a receiving flask at the other end. If you have mixture of liquids and you want to separate out one of these liquids, then you can use fractional distillation. You put the mixture of the liquids in the round bottom flask, you heat it, vapors starts to form, and then you use a fractionating column. The fractionating column has a higher temperature at the bottom and a lower temperature at the top. The liquid which has the lower boiling points will reach the top of the fractionating column as a gas or as vapors, and it will start to move through the leading condenser which has cooling water as well, and it will condense. So only the condensing liquid which has the lower boiling point will be collected first. Vapor chromatography is the analytical technique that is used to separate the different components of a mixture based on their interaction between a solvent or a mobile phase and a solid, which is the stationary phase. You start off by drawing a baseline or a start line using a pencil, not a pen, so it will not dissolve in the solvent. And then you put the different spots of the different component you want to put and the mixture, and then you immerse your filter paper in the liquid or in the solvent in a beaker and cover it, make sure that the start line is above the level of the solvent so that the different spots do not dissolve in the solvent and will disturb the chromatogram. And then when you leave it, the different component will interact with the solvent differently, and they will move at a different speed, and they will move at a different they will form at a different distance from the start line. The different definitions for chromatography. Chromatography is the separation technique. They have the mobile phase, which carries the soluble component of the mixture, and the greater the solubility of the component, the faster it moves. The stationary phase will slow the movement of the component attracted to it. The stronger the interaction, the slower the components move. The separation will depend on the balance, or will be the results of the balance between the components interaction with the stationary phase and the mobile phase. You can calculate the RF value for the movement of the different components in the mixture, where the RF is the distance moved by the spot measured from the start line until the center of the spot, and then the distance moved by the solvent, which can be measured from the start line to the solvent front. The RF value can be used to identify each component. It has a value between 0 and 1. 0 means the component did not move, which means it doesn't dissolve in that particular solvent that has been used. The state of matters, we have three different states of matter. Solids, which have a regular arrangement of the particles. The particles will only vibrate around about a fixed position. They are very close to each other, and they have definite volume and fixed shape. Liquids, on the other hand, are randomly arranged. They move around each other. They still have a close proximity to each other, but not very close like the solid. They have fixed volume, but they take the shape of the container. Gases are randomly arranged. They move quickly in all directions. They are so far apart, and they don't have definite volume or shape. The physical change between the states, which only changes the particles and but doesn't change the particles or their arrangement or their energy, but don't change the particles themselves. So the change from solid into a liquid is called melting. As the solid is heated, the particles will gain energy, and at the melting point, the particles will have enough energy to start moving and not just vibrate, and they will start to change from solid into a liquid. When the liquid is heated, this is and change into a gas. This is called boiling, and the particles will gain even more energy. They can now escape from the liquid, and they will have enough energy to become a gas. So at boiling point, the particle will have enough energy to break their intermolecular forces, and they will become a gas. And then a gas change into a liquid. This is called condensing. When the gas is cooled, the particles will lose the energy. They will move slower, and then the interaction between the particles will be regained. So at boiling point, the particle will have enough energy, enough intermolecular energy in between them, and then the gas will become a liquid. The change from liquid into a solid is called freezing. The liquid will cool, particles again lose energy. They will not be able to move anymore. They will just vibrate about their fixed position, and they will change from liquid into solid. The change from solid into a gas directly is called sublimation, while the change from gas to solid is called a deposition. Diffusion is the gradual movement of particles from places of high concentration to a place of lower concentration. We can see diffusion in the movement of particles through a liquid or a gas. An example of diffusion of a solid through a liquid is the diffusion of potassium manganate and water. When we add the potassium manganate, you can see that at the beginning the color is only at the bottom of the beaker, and then as the particles of potassium manganate starts to diffuse, the color will start to diffuse as well until they completely diffuses through the liquid. You can see the opposite as well. If you, in case of the color, if you dilute your solution, add more water, well, the color fades because the particle will be more separated around. You can see the movement of the particles through the movement or diffusion through air, as we can see in ammonia and hydrogen chloride. If you have this tube which is closed at both ends, and you put cotton wool soaked in aqueous ammonia on one end and cotton wool soaked in hydrogen chloride at the other end. Ammonia will start to diffuse from one end, and the hydrogen chloride diffuses through air on the other end until they meet each other and they form a ring of ammonium chloride, which is a solid. The ring is not at the center because the ammonia is smaller in size than hydrogen chloride, and it diffuses more quickly through air than hydrogen chloride, so it moves faster and a longer distance. The movement of particles also through gas can be seen through the movement of bromine gas and air. So when you have bromine gas in an inverted tube and you have an air in the other tube and they are separated by a glass plate, if you remove the glass plate, then you start to see that bromine gas will slowly diffuses through air until it completely diffuses through air, and the color will fade as well. Solution is formed when a solute starts to diffuse through a solvent and to form a solution. A solution is a mixture of a solute and solvent that do not separate out. A solute is the substance being dissolved, and a solvent is the liquid the solute dissolved in. A saturated solution is a solution where the maximum amount of solute has been dissolved, so no more solute can dissolve after that. Solubility is how much solute will dissolve in a solvent. It's measured in gram solute per 100 gram of the solvent. There is a graph of solubility versus temperature, and it's called the solubility curve. This is the solubility curve for the solubility of ammonium chloride, where the temperature is shown here on the x-axis, and the solubility in gram per 100 gram water is seen on the y-axis. Different substances have different solubility curves, and remember that the solubility of most solids will increase with the increase in temperature, while solubility of gases will decrease if the temperature increases. We can calculate the solubility by experiment. If we calculate the mass of a